Today we will discuss the problems related to Leibniz theorem. The problem based on Leibniz theorem. So first we understand about the or we remind the basic concept how to use the Leibniz theorem. So we have a function y is equal to fx. So when we do the first derivative we write down as dy, or this can be written as y1, or we can write down as y dash. We can write down as y dash, or we can write down this is f dash x. So this is for first derivative. So here we have the power of d is 1. So when we do the second derivative, we take the power as d2, second derivative. And we write down this as y2. We write down this as y double dash. We can write down this as f double dash x. So derivative is increasing. Suppose we have term y1. Okay, so when we do the nth derivative of this, so nth derivative of this y1 will be yn plus 1. So we add the nth derivative in y1. So y1 one time already इसका derivative हो रहा है, n time और derivative करना है. So then that can be written as yn plus 1. So we follow this thing into the problems. So that may we remember. Suppose we have y. We have y, so we write down the nth derivative. What is the nth derivative of y? Nth derivative of y is yn. We denote it as yn. So we write down directly nth derivative y is yn. Suppose we have term y1. So y1 nth derivative yn plus 1. Suppose we have term y2. So what is the nth derivative of y2? So nth derivative of y2 we write down yn plus 2. So we remember these basic things to solve the problems related to Leibniz theorem. So suppose we have one simple problem to find nth derivative. Find nth derivative of x square into y2 plus x y1 plus y is equal to 0. So first we remember this thing, the Leibniz theorem is used for the product function. So we have here is a product function, and we have product function in the second term also. The third term is the single function. So when we do the nth derivative of this particular differential equation, so we use the product rule in first term, and same we do in the second term. So now which term we can consider as u and v? So we consider those terms we can differentiate easily or finish the differentiation. So that means we prefer the algebraic functions. So we consider as v, and second function we consider as u. So generally we consider this y2 or this function as u, and x square we consider as v. v means इसका differentiation हम easily 2 to 3 terms में finish कर रहे हैं. Okay, so we remember the theorem. So for first term we apply the Leibniz theorem. Separately we apply the Leibniz theorem for second term also. So we do the nth derivative of. So differentiate n times. Differentiate n times. So we can write down this as dn of x square into y2 plus dn of x into y1 or plus dn into y is equal to 0. So this is the product function. So we use the nth derivative of this. So we write down first remembering the Leibniz theorem. So Leibniz theorem is dn of u into v is equal to nc0 dn u into v plus nc1 dn minus 1 u into dv plus nc2 d raised to the power n minus 2 u into d square v plus and so on. So first term nc0 means 1. Okay, so this x square we consider as v, this y2 we consider as u. So we write down the first term as nc0. You can write down nc0 into dnu. So n time derivative of u means y2. So dnu, u means y2, into v. v means x square, we write as it is, plus nc1, so dn minus 1 u, so dn minus 1 into u is y2 into dv, so differentiation of v means differentiation of x square, plus nc2 dn minus 2 into y2 into d square v x square. Parallelly, we see that means when we do the second derivative of this term, so this gives us the constant term. So differentiation of x square is 2x, or second derivative of 2x is 2. And now we do not write, or there is no need to write the further terms, because the derivative of this x square, 2 time derivative of x square is constant, so the further derivative will be 0. So further terms will be 0. So we stop the Leibniz theorem for first term here. So now we apply the Leibniz theorem for second term separately. So second term separately, so plus we write down for second term, so we write down nc0 and d raised to the power n into u here we consider u as y1 and v for x, into v means x, plus nc1 dn minus 1 into y1 or into dv means dx. So differentiation of x is 1, further derivative will be 0. Okay, so we stop the Leibniz theorem here and write down the last term. Last term is dn of y. So y का n time derivative क्या होगा? yn. So yn is equal to 0. Now we simplify. So nc0 means 1. N time derivative of y2 we write down as yn plus 2 into second this term write down x square. nc1 value is n and n minus 1 time derivative of y2 का n minus 1 time derivative, so this can be written as yn plus 1, मतलब y2 plus n minus 1, so means yn plus 1 into differentiation of x square is 2x plus nc2 value is n minus 1 upon factorial 2 into n minus 2 time of derivative y2 means yn, or 2 time derivative of x square is 2, plus nc0 is 1, derivative of y1 is n times, so we write on yn plus 1 into x, plus nc1 is n, and derivative of this is yn into differentiation of x is 1, or plus yn is equal to 0. So this 2 to this 2 cancel, factorial 2 value is 2. So now we write down this as x square into yn plus 2 plus 2nx yn plus 1, or plus this term we write down as n square minus n into yn plus x yn plus 1 plus nyn, or plus last term is yn is equal to 0. Now we write down this as x square into yn plus 2 plus, so here is yn plus 1, yn plus 1, so x yn plus 1 we can take as common, so we write on 2n plus 1 into x yn plus 1 plus, for this term yn and yn, so we take yn as common, so we write n square minus n or plus 1 into yn equal to 0. So the coefficient of this yn is n square minus n, the coefficient of this yn is n, or the coefficient of this yn is 1. So n to n cancelled, so we write down the term is x square into yn plus 2 plus 2n plus 1 into x into yn plus 1, or plus last term will be n square plus 1 into yn is equal to 0. So this is the nth derivative of given differential equation by using the Leibniz theorem. Okay, so first we understand which term we can consider as u or v. So algebraic function we consider as v, so we can differentiate easily or finish the differentiation up to 2 or 3 terms. Now rest term we consider as u. So we can write the nth derivative of that term. Now we move to the next question. Next question is if y is equal to sine m sine inverse x, sine into m sine inverse x, so then prove that one minus x square into yn plus 2 minus 2n plus 1 x into yn plus 1 plus m square minus n square into yn is equal to 0. So here you can see that means we also calculate the derivative of yn plus 2. So that means it is clear. So first we differentiate 2 times with respect to x, then we differentiate n times by using the Leibniz theorem. This is the best way. So first 2 times we differentiate 2 times normally. So we write down the solution of this. So given y is equal to sine into m sine inverse x. So we simply differentiate 1 with respect to x. So when we differentiate this with respect to x, so y1 is equal to differentiation of sine x. Sine x is cos x. Cos into m sine inverse x into differentiation of m sine inverse x. So m upon root 1 minus x square. Differentiation of sine inverse x is root 1 upon root 1 minus x square. Now we can write down this term as root 1 minus x square into y1 is equal to m cos m sine inverse x. So this is our equation number 2. So differentiate again with respect to x. So again we differentiate this with respect to x. So we use the first second. So this is our first function. This is the second function. So we have a differentiation of first. So what is the differentiation of first? So 1 by 2, 1 minus x square raised to the power minus 1 by 2 into minus 2x into second function we write down the same plus root 1 minus x square into y2. Differentiation of y1 is y2 is equal to m cos. Differentiation of cos is minus sine into m sine inverse x into differentiation of m sine inverse x root 1 minus x square. Now we write down this as the 2 to 2 cancelled. This term can be written as x upon root 1 minus x square into y1 plus root 1 minus x square into y2 is equal to, here we use the equation 1. So using 1, so this can be written as minus my. So this will be equal to y. So minus m into m square y upon root 1 minus x square. Now we multiply both sides by root 1 minus x square. So multiply both sides by root 1 minus x square. So first term we can write on x y1 plus 1 minus x square into y2 is equal to minus m square into y. So we can write down this term as 1 minus x square into y2 minus x y1 plus m square y is equal to 0. So this is our equation number 3. So when we get the second derivative, so now we differentiate 3 n times, differentiate 3n times with respect to x. So because we need a yn plus 2, so 2 time derivative we already calculated, so now we calculate the nth derivative. So similar, we do the same thing. So that means algebraic function 1 minus x square we take as v, and this y2 taken as u. Similarly for second term, we treat x as v and y1 as u. So we apply the theorem. So first n time derivative of u. So yn plus 2. 2 time derivative is already there, n times, so n plus 2 into v, write down same, plus nc1 value is n, so n minus 1 time derivative of u, so yn plus 1, derivative terms will be in decreasing order, okay. And differentiation of v, so differentiation of v is minus 2x plus nc2 n minus 1 upon factorial 2 into dn minus 2 time derivative of u, so this can be written yn into 2 time derivative of v, so this gives us 2. Okay, so we stop the Leibniz here because we have the constant term. Okay, next derivative will be 0, so next term will be 0. Now similarly we apply the Leibniz for second term, so we write down y n plus 1 into v plus nc1 means n, and yn, or differentiation of second term, 1 x is 1. Now next derivative of 1 is 0, so we stop here the Leibniz theorem, plus m square into y, and n time derivative of y is yn equal to 0. So now we simplify this, so we write down as 1 minus x square yn plus 2 minus 2nx yn plus 1, and this 2 cancelled, so we write down, this is a negative sign, so minus n square minus n into yn, n square minus n into yn, minus, this can be written as x yn plus 1 minus nyn plus m square yn is equal to 0. So 1 minus x square yn plus 2 minus, so x yn plus 1, x yn plus 1 we can take common, so minus, this gives us 2n plus 1 into x yn plus 1. So here we can take yn as common, so n square minus n, or this gives us plus n, or here we have the minus m square into yn is equal to 0. So n to n cancelled, so the answer is 1 minus x square into yn plus 2 minus 2n plus 1 x into yn plus 1 minus n square minus m square into yn is equal to 0. So this is our proof. N plus 2, 2n plus 1 x yn plus 1, or m square minus n square. Okay, so we take this term, we can write down this as yn plus 2 minus 2n plus 1 x yn plus 1. So when we take the plus sign here, so m we can write down as m square minus n square into yn is equal to 0. So this is our proof. Okay, so we move to the next question. So next question, if y is equal to a cos log x plus b sin log x, so then show that x square into yn plus 2 plus 2n plus 1 x yn plus 1 plus n square plus 1 into yn is equal to 0. So when we do the solution of this, so we write down as given that y is equal to a cos log x plus b sin log x. So this is our equation 1. So same thing we have to do here also, because we require n plus 2. So when we simply 2 time derivative and then n time derivative by using Leibniz theorem. So differentiate 1 with respect to x. So differentiate 1 with respect to x. So this gives us y1. Differentiation of y is y1. A. Differentiation of cos. Cos is minus sine. So minus sine into log x. And differentiation of log x is 1 upon x. Plus b. Differentiation of sine is cos. Cos into log x. And differentiation of log x is 1 upon x. So this 1 upon x taken into the LHS side. So this gives us xy1. xy1 equal to minus a sine log x plus b cos log x. So b cos log x. Now differentiate again with respect to x. So we differentiate this again. So LHS we see that the product function. So we use the x into y2 plus differentiation of x is 1 into second same y1 is equal to minus a. Differentiation of sine is cos into log x, and differentiation of log x is 1 upon x minus b. Differentiation of cos is sine, minus sine, so we use the minus sign here. Minus sine into log x, and differentiation of log x is 1 upon x. So again we multiply by x. So we write down as x square into y2 plus x y1 is equal to minus a cos log x minus b sin log x. So in this we can take negative sign as common, so can write down as a cos log x plus b sin log x. So we use equation number 1 here. So a cos log x plus b sin. So here we use the equation 1. So this is equal to the minus y. So we have this term. So x square y2. So we write down this term as x square into y2 plus x y1 or plus y equal to 0. So this is our equation number 2. Now we differentiate n times by using Leibniz. So when we differentiate this n times, so same thing we do. X square we consider as v, or y2 consider as u. Same for second. X consider as v and y1 consider as u. So apply the Leibniz theorem. So n time derivative of u means y2. Y2 का n time derivative yn plus 2. So yn plus 2 into v same as it is plus nc1 and into n minus 1 time derivative of yn plus 1 into 1 time derivative of u 2x plus nc2 and n minus 1 upon factorial 2 into n minus 2 time derivative of u yn, and 2 time derivative of v is 2. We stop the Leibniz theorem because we have the constant, further derivative will be 0. So plus we apply Leibniz theorem for second term separately. So we write down as yn plus 1 into second term xv plus n, or n minus 1 time derivative of y, 1 is yn, and differentiation of x is 1, and plus differentiation of y is yn equal to 0. So this can be written as x square yn plus 2 plus 2nx yn plus 1, and this 2 to 2 cancelled. So this can be written as n square minus n into yn plus x. So x square into yn plus 2 plus we can take x yn plus 1 common from these two terms. So 2n plus 1 x yn plus 1 or plus from this term we take as yn common. So this can be written as n square plus 1 into yn is equal to 0. So this is the proof.